All right, welcome. So, you're starting your journey in software engineering, and you're about to build some incredible things. But listen, every great builder needs a great toolbox. In this explainer, we're going to crack open that toolbox and get you fully equipped with the essential, fundamental tools you need to master, starting right from the ground up. So, here's a quick look at our roadmap. We're going to start with the big picture, the project blueprint itself, then we'll dive into the tools for design and for actually building things. And we'll wrap up by making sure everything works perfectly with quality checks and a final inspection of your skills. Okay, let's jump right in with the master plan for pretty much any software project out there, the Software Development Lifecycle, or SDLC for short. You can think of this as the overarching framework that guides everything else we're about to do. So the SDLC breaks down into these 8 distinct steps. And the whole point of having these steps, the real power here, is to take a project from just a fuzzy idea to a real working product. It's all about reducing risk, right? Each step makes sure you're building the right thing in the right way before you move on to the next one. Okay, this is one of those things that trips a lot of people up, so let's get it straight right now. Requirements are the what. They're the user's needs written in plain English so anyone, technical or not, can understand them. Specifications, that's how we'll prove it. These are precise, technical rules where everything is measurable. This is what turns a simple wish list into an actual engineering plan. All right, let's switch gears and grab our precision tools. Because here's the thing, before you ever type a single line of code, you have to think, you have to plan. This is the stage where we actually architect the logic that's going to power the whole application.
And you know what's wild? Every single complex algorithm you can possibly imagine, I'm talking from a simple sorting function all the way up to some crazy machine learning model, is built from just these 3 basic building blocks. That's it. Sequence, selection, and iteration. If you can master these 3, you can literally build anything.
So you've got a whole team, right? You've got designers, developers, testers. How do you make sure they're all speaking the same language? Well, that's where the data dictionary comes in. Think of it as a shared vocabulary for the entire project. It's the single source of truth that defines every piece of data so there's absolutely no confusion. And this right here is a perfect example of why this is so powerful. It completely eliminates any guesswork. We look at user ID and we know exactly what it is, an 8-byte integer that has to be positive. No questions. For the email, we know the size, we know the format. Locking this stuff down at the start saves you from a world of pain and bugs later on. Okay, the planning phase is over. Time to get our hands dirty and grab the building tools. This is where we take those designs and actually start constructing the software, bringing it all to life with code. You know, picking the right data structure is one of the most fundamental decisions you'll make as an engineer, and it's all about trade-offs. For example, a list is great because it's flexible and keeps everything in order. But if you need to find one specific item, you might have to search through the whole thing, which can be slow. A hash table, on the other hand, is lightning fast for lookups, like almost instant, perfect for finding a user by their ID. The catch? It doesn't care about the order you put things in. So, choosing the right tool for the job here makes a huge difference in performance.
All right, we've built something, but we're not done yet, not even close. Now it's time to open up the inspection tools. And listen, this is not an afterthought. This is a super critical phase where we methodically check our work to find and squash any bugs.
Yeah, and let's be clear, debugging is not just randomly changing code and hoping for the best. It's a science. It's a systematic process. You use a very specific set of tools to create a hypothesis about why something is broken, and then you use those tools to prove what your code is actually doing, which, believe me, is often very different from what you think it's doing. So your number 1 tool in this toolbox is the breakpoint. Its job is to answer a really simple but crucial question. Is my program even getting to this line of code? You set a breakpoint, run the program, and if it never stops, well, you've just proved your assumption was wrong and you found a massive clue about where the problem really is. Okay, so your breakpoint hits. Now you get to play detective. With single line stepping, you literally walk through your code one line at a time. You watch exactly which path it takes. Does it go into the if block or the else block? Does it enter the loop? This is how you catch the code red-handed, right when it makes a wrong turn. And while you're doing that step-by-step investigation, you use a watch. Think of it like putting a little tracker on a variable. You can see its value change in real time as you step through the code. So if you have a counter that should always be positive and you see it suddenly flip to -1, Bam! Your watch just showed you the exact line of code where your logic broke down. Okay, let's pull back from the nitty-gritty of the code for a minute and look at the management tools. These are the frameworks that organize the entire project, kind of like the foreman on a construction site, coordinating the whole team's effort over weeks or even months. And this slide just nails the core difference between the two big ones. Waterfall is like building a skyscraper. You have to have the complete, detailed blueprint finished before you ever pour the foundation. It's all sequential, step-by-step, and very rigid. Agile, on the other hand, is more like tending a garden. You work in these short little cycles, you see what grows, you get feedback, and you adapt your plan as you go. So the big question is, which one's better? And the honest answer is neither. It totally depends. There's no one-size-fits-all solution here. It really comes down to the project itself. Are you working on something with super strict regulations and a scope that absolutely cannot change? Waterfall might be your best bet. But what if the requirements are fuzzy and you know they're going to change a lot? Then you definitely want to go with Agile. All right, for our final section, let's do a quick inspection of your toolbox. We're going to run through a couple of classic scenarios, the kind of stuff you'll definitely see in a technical interview or on an exam, so you know exactly how to use these concepts to show you know your stuff. Okay, picture this. You're in an interview, and they hit you with this question. Compare a list and a hash table. This is a classic, and for good reason. It cuts right to the heart of your understanding of data structures. So how do you nail the answer? Here's the key. You start by hitting the main contrast right away. A list uses a numeric index to get to an element, while a hash table uses a unique key. Then, you immediately follow up with the classic engineering trade-off: order versus speed. Lists keep things in order, but hash tables give you way faster lookups. That's a home run answer. Okay, next up. They slide a piece of paper across the table with some pseudocode you've never seen before. It might look a little intimidating, so what's the very first thing you do to show that you can break it down logically? Right. The worst thing you can do is just start guessing. You need a system. A competent engineer will, first, identify the inputs and outputs, what goes in and what comes out. Second, they'll state its purpose in a single, clear sentence. And third, to really prove you get it, you trace the state of the key variables through one full pass of its main loop. That shows you understand the process, not just the result.
And that's a wrap. We've just unboxed the entire software engineer's toolbox. We've looked at everything from the high-level blueprints like the SDLC, down to the precision instruments like data dictionaries, and even the inspection tools you need for debugging. This is your foundation. This is what you'll use to build amazing things. So the only question I have for you is, which tool are you going to master first?